Galileo Galilei, an Italian astronomer, physicist, and engineer, remained one of the most influential figures in the history of science. His groundbreaking discovery and relentless pursuit of truth forever changed the way humanity perceived the universe. Born on February 15, 1564 in Pisa, Italy, Galileo laid the foundations for modern physics, observational astronomy. His pioneering work on motion, celestial observations, support for the heliocentric model challenge conventional wisdom, brought him into conflict with the Catholic Church. Galileo's story is one of the brilliant perseverance and controversy, an enduring legacy that continues to inspire scientists and thinkers today. Galileo was born into a moderately wealthy family, the eldest son in the Vincenzo Galileo, a musician, a music theorist. Galileo, although his father encouraged him to pursue medicine, Galileo displays a keen interest in mathematics and natural philosophy. In 1581, he enrolled at the University of Pisa to study medicines, but soon shifted his focus to mathematics after being captivated by the work of Euclid and Archimedes. His inquisitive nature and analytical mind led him to make significant contributions to the field of mechanics, particularly in understanding motion and gravity. One of the Galileo's most remarkable contributions to science was his study of motion. Through careful experimentations, he refuted Aristotle's long held belief that heavier objects fall faster than lighter ones. According to the legend, he demonstrated this principle by dropping objects of varying weight from the leaning tower of Pisa, proving that all objects, regardless of mass, fall at the same rate in the absence of air resistance. This discovery laid the groundwork for Newton's law of motion and the modern understanding of gravity. In addition to his work on motion, Galileo developed the concept of inertia. He proposed that an object in motion will remain in motion unless acted upon by an external force, a principle that would later be formalized by Isaac Newton in his first law of motion. Galileo meticulous observation and use of experimental methods mark a significant departure from the purely philosophy approach to science that dominated the era. Galileo's contributions to astronomy were equally revolutionary. In 1609, he heard about the inventions of the telescope, and without having seen one, designed and built his own improved version. He turned his telescopes to the heaven and made a series of astounding discoveries that challenged the traditional geocentric model of the universe, which held that the earth was the center of all celestial motion. His observations revealed that the moon had a rough, mountainous surface, contradicting the Aristotelians' belief that celestial bodies were perfect and unchanging. He discovers four large moons orbiting Jupiter, now known as the Galilean moon, proving that not all celestial objects revolve around the Earth. Additionally, he observed the phases of Venus, which provided strong evidence for the heliocentric model proposed by Copernicus, where planets orbit the sun rather than the earth. Galileo also noted the existence of countless stars beyond those visible to the naked eye, demonstrating the vastness of the universe. His finding, published in his book and the Starry Messengers in 1610, revolutionized the field of astronomy, provided tangible evidence that the geocentric model was flawed. Galileo's support for the heliocentric models brought him into direct conflict with the Roman Catholic Church, which upheld the traditional Ptolemaic system that placed the earth at the center of the universe. In 1660, the church formally condemned heliocentrism as heretical, and Galileo was warned to refrain from advocating it. However, he continued his research and in 1632 published Dialogue concerning the two-shaft world system, which defended the Copernican model. This book angered the church authorities, leading to Galileo's trial by the Roman Inquisitions. In 1633, he was found guilty of heresy and forced to rescind his views under the threat of several punishment. Galileo spent the remainder of his life under house arrest, where he continued his scientific work, including the studies on motions, mechanics, which would later influence Newtonian physics. Despite his persecutions, Galileo's contributions to science endured. His rigorous use of observations, experimentations, and mathematical analysis laid the foundations for the scientific methods, a systematic approach to inquiry that remains central to modern science. His work directly influenced the later development of physics, astronomy, and engineering. Galileo's legacy extends beyond science. He symbolized the power of intellectuals' courage in the face of dogma. Operations in 1992, after centuries of controversy, the Catholic Church formally acknowledged its error in condemning Galileo's, recognizing his immense contribution to human knowledge. Galileo Galilei lives and work exemplify the relentless pursuit of truth, the transformative power of science. His discovery shattered ancient misconceptions, paving the way for future generations of the scientists to explore, understand the cosmos. Today, he is rightfully celebrated as the father of modern science, a little earned through his brilliance, determinations, unwavering commitment to knowledge.